Sure. Yeah, my name is Adrian Smith. I'm a research scientist at the North Carolina Museum of Natural Sciences and also NC State University. And I'm an entomologist, and I'm mostly interested in the behavior of insects and closely related organisms. Yeah, springtails are mostly soil organisms that used to be qualified as insects. Now they're slightly outside of insects, or better referred to as a hexapod. And the ones I studied actually live in my backyard. So they're in the top layer of leaf litter and soil, and they're there eating microbes, eating bacteria, fungi. And their common name is springtail because a lot of springtails have a spring-loaded appendage they keep folded underneath their body that they can flip down against the ground and spring themselves away from danger. So that's what this study was focusing on, describing that part of their life. That's a good question because springtails are very abundant. They're one of the most abundant arthropods on Earth, but they're really small, so they don't get more than a few millimeters in body length. And the behaviors that they do, the jumping behaviors are really fast. So you have to film them with cameras that can reach up to, 40, 70,000 frames per second. Like in real life, and if you saw one of them and you got it to jump, like it would look like it's teleporting from here to here, like in less than a blink of an eye. And so they're difficult to see, and you need a fair bit of technology just to be able to see and describe them. So that might have been one of the reasons why they hadn't been paid attention to that much. Um, but there's a lot of things in the insect arthropod world that just hasn't been visualized before. And that's one of the things that excites me most about being a researcher is there's things I can go outside wherever I am and put in front of the camera. And it's likely that I've just filmed something or seen something that no one has before. And so that was certainly the case with these. This is one of our cameras. This is a Phantom high-speed camera, and this is a macro lens, so we have to be sort of magnified when we're looking at them. And this can capture them up to about 70,000 frames per second. Most of the data in the paper was at 40,000 frames per second or lower, down to maybe a couple thousand frames per second. But we need this giant camera to film these super, super tiny things. So it would be setting them up right about here in front of the lens, and then shining a big light. You need a lot of light to capture things with these, and then kind of hoping that we got the right behavior. So it's filming them, immediately getting off the ground, launching themselves, and then it's pulling back the camera a bunch to get the whole trajectory, and then it's trying to capture them actually coming back down and hitting the ground. So we had to film that at a bunch of different ways because we wanted to see. I wanted to see all the parts of what's involved in them getting off the ground and midair and landing and recovering. I wanted the whole thing to be captured. So it was, months and months of filming them with a camera like this. So yeah, so those globular springtails were the fastest backflipping organism. And now actually I have a graduate student in the lab who's working on the fastest front flipping organism, which is not a springtail. It's something called jumping plant lice, or a psyllid. Those are things that will feed off of plants. They have a piercing, sucking mouth part that they can feed off of the xylem phloem of plants. And to escape, they kind of use their hind legs to go end over end in front. And they do a couple of front flips really fast, and they fold out their wings and fly away. And those are also local. So you can find those. They're very common where we are here in the Eastern US. So yeah, we're working on describing similar, it's kind of high speed escape mechanisms of insects that are all around us. Yeah, I'm collaborating with some researchers at Georgia Tech who do a lot of that technology transfer that think about these things in terms of engineering or robotics, and that's certainly a next step that we're pursuing with these springtails. But for me, what interests me in it is setting the foundation for that work is really the basic biological descriptions, because we can make better robots, we can get better engineering principles once we have a fuller understanding about what's out there in nature. And so, there are thousands of species of globular springtails, and this is the of springtails in general, and this is one of the first efforts to fully describe what they can do. And it's likely once we look in other systems that we'll find variations of that, or new ways that they're doing things that we didn't even imagine. So I like to work with those applications, but first I like to kind of do the groundwork of describing the biology and all the variation that's out there in the first place. And I think that's a kind of the best way to start at getting at some of those, you know, taking it into robotics or engineering, is first you need a really good foundation of what's out there in the first place. Well, for about a decade, I focused mostly on ants. And so I was exclusively an ant researcher, interested in behavior and communication and biology of those insects. And in more recent years, I got really interested in seeing what I can find around me, that is both extraordinary and understudied. And so that's led me to work on things like springtails. But we also work on I have a student working on roaches at the moment, a student that just graduated that worked on fleas, and like I said, another student who's working on jumping plant lice. So I've really been fascinated on expanding out from things like ants to be a more sort of generalist entomologist, and look for interesting bits of the natural world that we can describe and we can tell people about at the same time.